Hello everyone, I am the Snitter and welcome to another game dev video. Now, before you ask, I know there is no video labeled part 1. However, I made a video a few weeks ago called GMS2 1 Hour Challenge Making a 3D Gravity Platformer. In that video I showed how to set up a 3D camera, move the camera with the mouse, make a vertex format, make a spherical vertex buffer, control the player in full 3D, verlet integration and spherical collisions. All of this was made in a single hour. And that was an exhilarating experience, and I figured that it might be fun for both you and me to continue the project as a YouTube series. So, in case you haven't seen the previous video, here's a short version of what it does. The level is stored as a list of planets. At the moment they're all spheres, but that will change soon. Anyway, to figure out which planet is closest, we need to find the distance to each planet. What we're actually interested in is the distance to the surface of the planet, so we need to subtract the planet's radius from the distance. The one with the shortest distance is our planet. Then we can normalize the vector from the planet to the player to create the player's up vector, and this is used to orient the player and to apply gravity. To apply gravity, you just subtract this, multiplied by some factor, to the player's position each step. To make sure the player doesn't go inside the planet, just check the distance between them. If it is smaller than the planet's radius plus the player's radius, the player is inside the planet, and we have to push him back out. Today's video, I'd like to continue where I left off last time. My main goal today will be to add more primitives, and I will show you how to draw and collide with a capsule, a torus, and a disk. I will also show you a neat little trick to allow you to reuse primitive vertex buffers. So if you go through the different objects I'm going to add today first, this is a capsule. A capsule is defined by a line between 2 points and the radius from this line. And you can think of it as a tube connecting two half spheres. Avoiding the capsule requires finding the nearest point, so if you have the player here, you have to find the nearest point to the player on the axis and displace the player along that axis. Once you have the nearest point, the process is pretty much the same as for a sphere. I'm also gonna add a torus, which is basically a donut. A torus is defined by a large radius, a small radius, a position, and a normal. And they are all written here. So the small radius is the radius of the tube. The large radius is the radius of the ring. The position is basically just the 3D position in space. And the normal is a vector, a unit vector that is perpendicular to the plane of the ring. So we need to project the player's position down onto the plane defined by the normal. We can normalize that and multiply by the radius of the ring to find the nearest point inside the tube. And then we can use that in the same way that we avoid a sphere and just displace the player along that vector. So, the last thing I want to show you is how to do non-uniform scaling. Normally, when you create a vertex buffer, you'll want to store the actual coordinates of each vertex. However, for basic primitives such as these, there is a better way of doing it to allow you to reuse your vertex buffers. So for the top one, I have basically baked the vertex coordinates into the vertex buffer, and in the lower one, I have only stored the central position in the vertex format, in the vertex buffer, I mean. And in a shader, I displace the vertex along the normal. So if we then stretch these two vertex buffers by the same amount, you can see what happens when you have baked the positions. The ends will be stretched. And when you have only stored the central position and displaced the vector, the vertex in a shader, the ends stay looking like hemispheres. So if we go back and then scale again, you can see what happens. And that's it for the intro. Switching over to the live stream in 3, 2, 1. There you go.
Yes,
there we go. Good evening and welcome to my video about, today I'm gonna record while I continue working on the 3D gravity platformer that I started working on a couple of weeks ago. But first, if you are interested in 3D programming in GameMaker, you should definitely join the 3D in GameMaker channel in the GameMaker Discord. So let's see. I'm gonna actually use the source from the video, so you can download this yourself if you'd like to follow. This is basically a, let's see, find the result. Let's see. Yeah, this was made in 1 hour. It's a 3D gravity platformer where you fall towards the planet and you can walk from planet to planet. And today I'd like to add more kinds of planets. Let's see. I'm just going to download this and let's hope it opens in GameMaker. And there we go. I'm just going to start it so you can see what it looks like. You can control the camera with the mouse, so just right click and you can move the camera on the player, and you can move with the WASD buttons. No, don't leave. Okay, you're allowed to leave. I'm gonna record this anyway and put it on YouTube, so if you'd like to watch later, you're allowed to. Sleep well, Patrick. Let's see. Yes, so the first thing I'm going to do is just clean up the project a little bit, because this was all made in 1 hour and there's a lot of junk in the code. Yeah, it would be awesome if you'd stay and keep me company. Let's see. The first thing I'm going to do is just clean up the project resource tree first. Let's see, let's add a folder for shaders and one for textures. Yep, so I'm just going to keep it as one object still. Now, there are many geometric shapes that are possible to add. I think the first one I'm going to add is a cylinder, because that is basically just like a sphere, or more like two spheres, like where one sphere is a central position. You can see that as a beautiful sphere, where a sphere has a position and, let's say, a radius. A cylinder has two positions. And just to make this easy, I'll make a rounded cylinder so that the edge is spherical, like that. Let's see. So this is my beautiful cylinder, and I have a central axis here, while the radius is still up there. Let's see. Okay, and this is going to be P1 and P2. So that's my goal for today. Is it a face? What's a face? The left one. Yeah, it's a kind of a whale, I guess. Let's see. Okay, so what do we have to work with here? I'm going to make the text bigger because that was the main feedback from the previous video. The text was too small. This is the step event. I would like to start in the create event. So let's just organize ourselves here. The level is created by adding spheres one at a time to a list of geometry. Now this can be put into a single function, so just to clean it up a little bit, I'll make this a separate function called add sphere. Let's say and I'll use this to create one sphere at the center of the world with a radius of 150, and let's see that it still works. Yes, so now we have a single planet in the center of the world. I would actually like to change the vertex format a little bit, because right now it only has a position and a texture coordinate, and that works for a sphere because the position is also the normal kind of, but that doesn't apply for a cylinder, so it needs a separate normal. And I'm also going to change the way things are drawn. I'm going to use the shader. Let's see here, because I use the world matrix to transform. So I can still use the position, but I want to send this as a uniform instead. So I need to use this as the normal instead. Let's see. Am I going to make this into full game? Maybe. My plan is basically to just continue working on this and trying to explain different concepts when it comes to 3D game programming. Like in the first video, I explained how to transform the player independent of which direction is pointing up, so that you can, like, if the up direction is pointing sideways, you still jump sideways. You don't jump up in the positive Z direction. There is probably a better way of explaining that, but it's it's late evening here, so yeah. My goal is just to show what is possible to do with GameMaker. I'm no longer bound by the vanilla GameMaker setup, so I can use like existing scripts, I can use existing tools. So now in the early phase, I'm just going to use like basic geometric shapes like spheres, cylinders, cubes, donuts, for example. Maybe I'll add a donut and a disc as well today. I'll see what I have time for. And later, I'd like for that to only be the gravity direction object, and that you can collide with level models, OBJ files. Because, you know, like I have the collision mesh scripts that I've made specifically for this this use. Let's see, I need to think here, because I have to add the normal, and I actually want to replace this with the normal. And I'm going to show you something cool, because I can use 0, 0, 0 as the vertex position. and only store the vertex position in the normal. Good evening, Bart. I assume that's you. Tune is Bart. Let's see. Yes. Okay, I'm gonna move this into its own separate function. Matrix orthogonalize. Let's see. Create script. Math. Let's keep all the math in there. And I also need to figure out where I have used that script. Yeah, excellent. Good to see you here. Okay, so I have changed the vertex format. I have added a normal to the vertex buffer. The next step is to change the shaders, because both of these use the same format, so I need to change both shaders. In normal. And I also need to add a uniform radius. Let's see, I'll remove the unnecessary bloat, and I'll use the world. Let's see, I'm gonna split up this. I don't want to use the combined matrices. I actually want to multiply by the world matrix up here. And if I remove world, I think, yeah, that's not a built-in matrix. I need to split up these as well. So I'll have to do projection times view. I'll change this to world space. And now the thing here is that the world matrix may be scaled differently in all directions, but I want the normal to always be uniformly scaled. So I'll have to create a new matrix. Let's see. That should be matrix 3. Normal matrix. And I have to divide it by the length of each vector. Let's see. Okay, and then I offset the world space position with xyz plus equals in normal times u radius, and I use this there. Okay, I think that should be it, and I need to do the same here. And I know this is a lot to keep track of, and I have no idea if this will actually work on the first try, but I mean, we'll figure out soon. There we go. Okay, let's send that to the shader as well. I need to go to the old system, draw. So I've set the scale to 1. Now I need to set the shader uniform F. Let's get the SH planet view radius. And that should be the radius of the sphere. And I need to do the same down here. And 1. And if I have done everything correctly, nothing should look different at all. Like, it should look exactly the same. Let's see. I am as excited as you are. Nothing worked. Let's see, I forgot something. I have an extra parenthesis. Okay, let's try again. And it works, but the shading is broken, and I think I know why. Let's see. World normal. And I'll use that in the, oh wait, let's see. I don't have to normalize that actually. Okay, what happens now? Yeah. Okay, so that is a lot of like background work out of the way. This will make it a lot easier to make other geometric shapes, because then I can reuse the vertex format, the vertex buffer, I mean. If you bake the vertex position of each shape, like for example a cylinder, it can have varying thickness, it can have varying length, and like if you have to create a new vertex buffer for each combination of radii and lengths, that is a lot of vertex buffers. So what I want to do instead is to create a single vertex buffer and then basically just tell the shader how to distort it to account for any kind of cylinder or any kind of torus for that matter. Like the inner ring sometimes is different from the outer ring. That didn't make a lot of sense, but okay, let's just let's just continue here. So I have a function for creating a sphere. Let's create a new function for creating a rounded cylinder. And I'm gonna copy this and use this as a basis, because if you look here, you can split this shape into three. Like you have one half sphere there, one half sphere there, and then a tube in between. So I want to draw like half a sphere at one side, half a sphere at the other side, and then a tube in between. So I'll try to draw the hemispheres first. Yes. Okay, let's draw one hemisphere first. This should still be 2 pi. This should actually be 1/2 pi, since it's a hemisphere. I'll name this create cylinder. It's going to be capsule. Yeah, I guess capsule is a better word. It's definitely actually, let's name it a capsule. Excellent suggestion. Okay, let's say capsule. I'll use the same arguments. Let's add capsule geometry object. Let's say add capsule. So, like I said, the capsule needs 2 positions, so I'll use x1, y1, z1, x2, y2, z2, and r. I'll just copy these over. Let's see, there we go. And instead of a central sphere, I'll add a central capsule. Let's make that from 0, 0, 0 to 500, 0, 0, just for the time being. And there are 2 steps I need to do before I can test this. I need to make the player collision, and I'm just going to copy the sphere for now, and I can improve that later. Let's see, but this needs to be index. Let's say 1, 2, 3, 4, 5, 6, 7. There we go. And when drawing, I would like to use capsule model. That should be index 7. And I'm just going to see what happens now. Okay, it draws half a sphere, which is exactly what it should do. But does it draw the correct half? I have no idea. But I can actually just continue and see what happens by adding, let's see, draw the bottom hemisphere. Let's call it a bottom and draw top hemisphere. Okay, so I need to make the Z direction negative. I need to add 1 there at the position, and I'll make the Z normal negative. And I think this will draw inside out. Let's see. Yeah. But it is actually at the wrong position. Let's see. So it's this one that should be negative, and this one positive. And I need to change the order of these to make it draw the correct way. And let's see what happens now. Yes, okay. So this is exactly what I wanted. I wanted them to draw the correct way with a small gap between them. That small gap is this single unit offset. Yes. Now I can use the scale. Let me think. Okay, I have 2 positions and I would like to create a matrix that points from one position to the other. Creating a matrix from a single vector it's possible, but it's a bit risky because you also need to use a second reference vector. So what I like to do is to use a vector that usually is never parallel to any other arbitrary vector. I'm just talking nonsense. Let me show you what I'm talking about. I'm gonna add a little bit of code here, and that's gonna be a temporary piece of code. Let's see. So a lot of what I'm doing today is gonna be cleaned up later. 4, 5, 6. But I want to create a new matrix. Build identity. And I would like the up direction to point from position 1 to position 2. Now the up direction is index 8, 9, and 10. I could use 0, 0, 1 and for special cases use a different one, but I have a different solution that also works, kind of. I'll show you. Let's see, 8 equals, and that should be sx2 minus sx1, and I'll do the same for the other 2 dimensions. Let's say Z. And then for the perpendicular direction, I will use 1 for the x-axis, pi for the y-axis, and a square root of 2 for the z-axis. What do you think about that? Let's see, and then I will orthogonalize this. Yeah. I actually think this will work. Yes, I guess this is a magic number. I mean, I only really need the this vector, and this is only going to be like to get some kind of perpendicular vector, and whatever I mean, it's only an arbitrary perpendicular vector. I know it's slightly illegal to do it this way, but I mean, I'm the programmer. Okay, so I have orthogonalized the matrix, and I would like to multiply the up vector by the length, or the distance from the first position to the second. Hi, Railway. So I'll need to get the distance. Sx1, let's see, S11, SZ1, Sx2, Sy2, Sz2, and h times it is just 9, 10. Okay, and you can see here I use Sx, Sy, Sz as the position. Now I need to use the first position. So the position is stored in the 12th, 13th, and 14th index. So I'll just set that manually here. And then I'll use this here, and let's see what happens. Okay, you can see here, actually I haven't fixed the collision, so even though it looks like a cylinder, actually it doesn't even look like a cylinder, bro. Why I don't have the Discord client installed? I don't know, I've never had use for it. I mean, the browser version works perfectly well for me. So I don't know if you can see it, but this is half the, or one end of the cylinder, and the other side is over there. You can just see the outer edge of it. So I think this is working correctly, but I have to do some more steps before it works perfectly. So I have the bottom, I have the top, and I need the tube in between. And I can have that here. Let's see. So now I need to make, I have everything I need right here. Let me just try this. I actually think this is all that's needed. I need to fix the vertex coordinates still, but no, that did not work at all. Let's see, why did that not work? Built-in variable, what variable is not set? The y variable, oh right. Yeah, that makes sense. This should be 0, this should be 0, this should be vrep. 0, vrep, vrep. Let's try again. Okay, well that's something. One of them is inverted. Let's try inverting this one. And there we have a capsule. So now it draws correctly, and now I only need to fix the collision because I'm still just colliding with the sphere. So this is a pretty interesting step. I'll just leave this for now, let's go into the collision code. Yeah, it is a cool palette, thank you. Let's see. I'm just gonna comment out all of this for now. Yeah, it is. Let's see. Oh, I removed the gravity. No, the collision code. Okay, so I'm getting the first position. I need to get the second position as well. 4, 5, 6. So let's switch back to the drawing board. Let's see. I just got a drawing tablet, so I'm still getting used to that, but let me see if I can draw here. So let's assume that the player is over there. So this is the player object. Am I able to write here as well? Maybe player. Beautiful handwriting. So I have two vectors to work with. I have the vector going from P1 to P2. Let's call that, let's see, actually I can just do this. Let's call that P vector. And I also have a vector going from P1 to the player. What should I call that? I'm gonna be completely original here, and I'm gonna call it vector V. So what I want to find is the nearest position from the player onto this line here, going from P1 to P2. So basically around, let's see, there. So what I can do here is just a little piece of vector math. I can do like the dot product between that vector, and that will return like the length of V times the length of P times the cosine of the two vectors. And let's see if I can use that for anything. So I'll just switch back here. So what should we call them? Cap dx. For capsule, let's say y and z, and player dx for the player vector. Say z. And let's get the dot product. That's cap dx times player dx. y, z. Now there's one problem here, because I want this to be a unit vector, but it isn't. But I'm going to use the dot product to multiply with this vector later, so I don't have to use the square root. I can actually just use the square of the distance between them. So I can do this. There we go. No square roots involved. But now dp can be smaller than 0, it can be larger than 0, larger than 1. And I don't want that, so I need to clamp it. And dp equals clamp dp to 1. And let's see, maybe I can use some of this. I think actually I can do that. Let's see. Because there I'm using sx, yeah. and that is sx1 plus cap dx times dp. Y, z, z. I think this should work. Do you think it will work? Oh yeah. We have working capsules. So the nice thing about doing the, let's see, the fact that I'm sending the radius of the capsule as a uniform is that you can actually change the capsule while the game is running. Let's see, I'm just going to do something crazy here. 500 plus 200 times the cosine of current time over 100, and let's see what happens. And this is just playing around. Yeah. I don't know why I did that, but I mean, you can see that the the length of the capsule is changing while the radius stays the same, and even like the hemisphere at the end, it doesn't change even though the capsule stretches. Let's see. Okay, so that is a capsule, and there is a lot that can be done to like optimize this code, but I'm going to leave it like this, and I'm going to continue by adding a new shape, the torus. I'm going to add a donut. Let's see, let's go into create event, and it's basically the same process all over again, except for a slightly different geometric shape. I'll actually copy the sphere function again. Create a torus. Okay, so I have two loops, which is exactly what I need. And let's see. Yeah, perfect. So the position should be, and let's make this so that the ring stretches along the xy dimension, and that means that I should use xc1, xs1, 0 for position. There we go. So this is only storing the middle of the ring, and this is going to store the offset of the ring, which means that this is actually correct. Is it? No. Wait, yes it is. That is actually correct. And this one is also correct. I think I think I've already created a torus. Let's see what happens if I do this. Torus model equals create torus 32, 16, 5, 5. I'll add a torus to the world. And what info does a torus need? Well, we need to tell it that it is a torus. Add torus. Okay, so it needs 2 radii. It needs a position. Let's say x, y, z, r1, r2. Do we need anything else? No, I don't think we do. Yeah. No, actually, we do need something else. We need to store what direction it's pointing. And how should we do that? Maybe with a normal vector. And x, and y, and z. Actually, I want to test the torus a little bit more. I want to make sure that it works even if it's pointing in a different non-axis aligned direction. Yeah, it is. Okay. Let's test the torus. Let's add it at the 0, 0, 0. Let's make it point towards 0, 0, 1. Let's make the outer ring like 400 and the inner ring 100. And if anything makes no sense at all, just ask. I love answering questions if you have any. Let's see. And I'll copy the sphere collision just as a temporary solution. Torus. And let's use the outer radius, which is 1, 2, 3, 4, 5, 6. Just going to see what happens. When drawing, I'll use index 6. Wait, I think, okay, that is something at least. Okay, let's see. I actually need this to be, let's see, R1 equals geo 6, R2 equals a geo 7. Now this needs to be R1, and this needs to be R2 over R1. Let's see what happens now. Maybe it should be R2. Well, that doesn't make sense. Let's see here. Why did it disappear when I did that? Oh, right. Let's see. 7, 8. Ah, that might be the problem. Let's see. R1, R1, R1. Oh, okay. So it's only drawing half. Let's see. And that means that this needs to be 2 pi. Whoa. That was the wrong function. Let's see here. There we go. Yeah, we're getting somewhere. Okay, the collision makes no sense, but at least we are drawing a torus. Okay, let's make this R1, R1, R1. Let's see what happens then. Perfect. Okay, so now we have a perfect torus, and now we can collide with it. Maybe I should use tau instead of pi. So I have the central position. I need the normal. Y, Z, 5, 6. I have the first radius. And I have the second radius. Okay, sleep well, Patrick. Thank you for joining me. Hi. Excellent. I'll see you around. So, I have a script called matrix orthogonalize. I'm gonna make a simpler version of this where I only orthogonalize one vector to another. So one vector to a normal. Let's see. Actually, I'll just do it here. Orthogonalize player delta vector. Y, Z, Y, Y, Z, Z. There we go. And then I need to normalize there, delta vector. Actually, I'm gonna call this, let's see, I'm gonna call this Torus X, Torus Y, Torus Z. There we go. Normalize the new vector L equals let's see, it should be R1 over SQRT L. 6 times equals L. I'm just going to see what happens now. And the game actually, the game froze. Okay, why did it freeze? Let's see. Maybe it's because I'm exiting. I'm getting tired. Let's see. Torus X is not a variable. Y, Z. Oh, would you look at that? Yeah, the Torus normal is the vector that like points perpendicularly to the ring. So I actually create that here. In the add Torus function, I made a vector 0, 0, 1. So that is just manually input here. Now there is one problem, and that is that when the player is in the exact middle of the torus, he just falls through. So when I move slightly, then he starts falling toward the torus. So I need to fix that. Step. Let's see. And I think that's because of this. Less than or equal to, and Sx equals 1, else. No, I think that should work. Let's see. Okay. There we go. Now you can move all the way around a torus as well. So now we have three shapes to work with. And I don't know. I'm actually quickly gonna add one more shape. And I promise this will only take a couple of minutes. I'm gonna add a disk. And that is basically the same as a torus disk. Except it isn't hollow. It doesn't have like a hole through it. But it will have the same arguments. Disk. Create disk. This should not be 2π, it should be just pi. And I need to also create the lid on each side. Let's see. And this is pretty simple actually. Because now I need 3 positions. I need the that and that. Right, I need to also use the 1, 0 there and there. Let's do that for the other side as well. This is the draw event. Case disk. Actually, I'm just no. Disk model. And I'll go here. Let's say disk model, create disk, and step event. For now, I'll just copy the torus case disk, and let's see what happens. Didn't I change that? Let's see. Add disk, and I need to call it a disk as well. What happens now? Okay, but it won't draw on this side. Capsule and disk. So I'll just switch these two and see what happens. Yeah, now we are drawing a disk. And I will also make the collision work, and that is a pretty simple modification of the torus collision. Instead of multiplying by r, let's say I want to multiply by minimum of the SQRT L and R1. I think that's all that's needed, actually. Let's try that. Yeah. Okay, there we go. So just to finish up this little video, I'm gonna make a simple level with all of these shapes. So I'll have a sphere at the center. Then a capsule, and I'll offset this by, let's say, 400, 500, 200. And let's make this a thin cylinder. And then let's add a torus. I'll make this like 600 in, no, let's see, 600 in that direction. Let's make that 400. And finally a disk, and I'll offset this minus 300, minus 200. Okay, let's just see what happens now. That's a huge disk. Okay, let's see if we can move between them as well. Yeah, there we go. Can we make the jump up there? Maybe if we circle around here. Yeah, there we go. Okay, so all the shapes seem to work as intended. Let's see if I can make it back to the cylinder. And I know I am flying. I am basically orbiting just to make it a little bit higher up. Okay, so that's it for this video. Thank you for paying attention. This has been fun, and we are one step closer to something along the lines of Mario Galaxy. Yeah, great. I'll see you around. Maybe I'll make the next video a little earlier in the day so that I'm not I'm not ready for sleep. Yeah. I'm going to bed. Sleep well.